Hi, have you ever wondered what has made this world a tiny place? How do you get to watch your favorite web series stored miles away from you? How does your Insta posts and snaps reach your friend in no time? You will probably answer internet, isn't it? And yes, you are absolutely right. But internet is huge. But have you ever given it a thought how this gigantic web is running and serving billions of people around the globe? Today we will unveil this mystery. Call me Anirban, and today we will talk about the foundation of the internet, that is BGP. So today our agenda is this. First we will get a brief on computer networks. Then we will discuss a very important topic, that is routing protocols. Finishing this, we shall look into the topic of the day, that is BGP. We shall see how it works and understand its nuts and bolts. We will then cover two of the most important concepts, that is autonomous systems and path attributes. Finally, we will conclude this video by discussing on improvements of BGP over these years. So let me ask you that good old boring question. What is a computer network? Whenever you connect two devices so that they can communicate, you build a network. Be it a small scale implementation spanning across a room, or be it something that spans throughout the globe, everything is a network. Networks have changed the life of millions, but how does it really work? When you want to access something that is stored somewhere else, you first need to find a correct route to reach that resource. Internet is a graph that contains trillions of nodes and edges. Graph traversing algorithms are of no use here. There are special devices called routers that route your requests. But that doesn't solve our question. How does a router know which side to forward the request? So there is something called routing protocol that helps us achieve this. Routing protocol is the language spoken by the routers to convey information about the network to each other. This way, every router ends up with full or partial information about the network, and they can now forward your traffic on correct wire. Speaking of routing protocols, there are different types, each made for different size networks. Routers with help of routing protocols communicate information about the network. Such information is stored on a router's routing table and is used by routers to make the forwarding decisions. Routing protocols can be broadly classified into interior gateway protocols and exterior gateway protocols. IGP are the ones that work within an organization, or we can simply say for small networks, whereas EGP are the ones that work externally and connects organizations, or we can simply say for large networks. Based on how a routing protocol works, they can be classified as distance vector, link state, advanced distance vector, or path vector. Every type has their own characteristics, pros and cons. DEEP is a distance vector routing protocol, whereas OSPF and ISIS fall under the category of link state routing protocol. EIGRP is an example of advanced distance vector routing protocol. All these are IGPs. BGP is a EGP that is widely used and is a path vector protocol. At this point, we already know what is a routing protocol. Now we shall dive with BGP and understand how it is the foundation of the internet. Simply putting, BGP is the routing protocol that is running the internet. BGP is specifically a path vector routing protocol. Without BGP, the internet will break apart. BGP routers exchange network layer reachability information or NLRI among themselves to learn about the network. Unlike other protocols, BGP works very differently and is quite complex. when compared to other routing protocols. To understand BGP, we need to understand two most important concepts, that is BGP autonomous system and path attributes. Now let's try to understand what is an autonomous system. Previously, I described routing protocol and I used the term organizations. However, a better and more technical term is autonomous system. So what exactly is an autonomous system? Autonomous system is a group of routers and networks working under a single administrative domain. BGP, which connects the massive inter-network called the internet, do not work at the router level. Instead, works at the group of router level. This group of router is nothing but autonomous system. Simply putting, BGP connects the autonomous systems throughout the internet, whereas AS is under the control of some network operator. When routers establish a cross AS connection, we call it an eBGP or exterior BGP neighbor. When routers connect within an AS, it forms iBGP neighbor. BGP has a very effective loop prevention mechanism both at the exterior and interior level. When a NLRI or simply saying a route is advertised from one AS to another, then routers add their AS to the AS set value of the NLRI. AS set is an array of AS that the router has already passed through. Whenever an AS receives a NLRI which already contains the current AS, the router ignores it, thus preventing loop at the exterior level. It is a core rule of BGP that prevents formation of any loop. Now, since we know what is an AS, let's try to understand BGP path attributes. BGP uses a list of parameters to compare NLRI and to decide which is a better route. Path attributes include next hop, local preference, locally originated, AS path, origin, MED, neighbor type, IGP metric, and etc. Path attributes affect choices both at the interior level and at the exterior level. These path attributes can be majorly classified based on well-known and optional attributes. Well-known attributes are the ones that every BGP implementation must support. Well-known can again be divided into mandatory and discretionary. Mandatory being the attributes that must be included in every update, whereas discretionary are the ones we do not need to present in every update. Optional attributes are the ones that need not to be supported by every BGP implementation. Optional path attributes can also be classified based on transitive and non-transitive. So the final topic that we will cover today is improvements in BGP. BGP has been there since a long time, and over years BGP has been improved a lot. The most important improvement that has been done is MPBGP, which stands for Multi-Protocol BGP. MPBGP added the support for address families. MPBGP supports address family identifier, which is either IPv4 or IPv6. Moreover, AFI is also divided into subsequent AFI, that is either unicast or multicast. MPBGP also added the support for exchanging VPN labels. A router can also run multiple BGP instances by using VRF, that is virtual routing and forwarding. So that's all with BGP. Thank you for watching.